ISHRI, Indian Society of Heating, Refrigerating and Air Conditioning Engineers. Founded in 1981 at New Delhi by a group of eminent HVAC and R professionals, ISHRI now has a total of 41 chapters and sub-chapters.
ISHRI gives you the latest industry insights of the HVAC and R and building industry and delivers latest technologies in forms of technical blogs, videos, and articles to people. It has more than 14,000 members and about more than 10,000 student members. ISHRI releases various standards for HVAC and R building industry time to time. It organizes more than 800 events every year, including seminars, conferences, product presentation and more. ISHRI also provides handbooks and guidelines. ISHRI also has student chapters in more than 150 engineering colleges, to encourage students, and let them know about HVAC and our industry. Visit now, ishri.in, for more details.
Good evening, all of you. Ravi, I just wanted to check whether the screen is visible.
Yes, sir. Yes, sir. Your screen and voice is perfectly fine.
Okay, thank you. Welcome all the delegates for this webinar series. Today is this session 6, 7th of August, and the topic is use of ammonia refrigerant for comfort air conditioning. Webinar series conducted by ISHRI on refrigeration applications using natural refrigerants. And the speaker, Mr. Ramesh P. Paranjpet. Our honorable speaker for today's session, Shri Ramesh Paranjpet, is the fellow life member of ASHRAE. He has been awarded the Distinguished 50 Years Service Award from ASHRAE this year in 2020. He is the member of ASHRAE Fundamentals Handbook 2017 volume. He is the member in the committee. He is also the member of IIAR USA, and by qualification, he holds an MTech from refrigeration from IIT Mumbai. Professional experience is 6 years as the Chief Executive Officer at Voltas Air International Limited, Pune, 4.5 years as the Managing Director, Carrier Refrigeration Limited in Bangalore and Singapore. And prior to that, 27 years of service at Kirloskar Pneumatics Limited, Pune, and where he was the Vice President. Mr. Paranjpet, other than from the working in the industry, parallelly he also contributed. He was the examiner and the paper setter in the University of Pune for Master in Engineering and in Syllabus Formulating Committee. He has published more than 45 papers in international and national journals. Has conducted more than 300 training programs at Honeywell, Alpha Level, Voltas, Blue Star, Thermax, Emerson, Tata Motors, LG, and ASHRAE forums, and on international levels in US, Singapore, China, Germany. Now, the reason for getting the ASHRAE Fellowship Distinguished Award is because he is been meeting the ASHRAE objectives in sharing knowledge and information through publishing papers and conducting training programs, as well as promoting the arts and science of refrigeration and air conditioning. It's a big honor to get this ASHRAE Fellowship, and I would like to again congratulate Sri Paranjpet for this effort and this achievement. So these other achievements are he's been invited by the German Chamber of Commerce to deliver a lecture in Germany on ammonia pump circulation systems for low temperature applications, and that was in the year 2008. He presented the paper at IAR conference in Macedonia on energy saving techniques in ammonia pump circulation systems. He was the winner of the Braille Systems Design Award in the year 2009, winner of the Lifetime Engineering ICE Danfoss Global Change Award during the year 2012. He's published a book on cold room solutions for Emerson Climate Technology. Has published a book for Danfoss Controls on how to use ammonia, making it easy and safe and to be efficient in the year 2000, during the year 2012 and 15. Has published a book on air-cooled design for cold storages for alpha level in the year 2015, and has executed more than 700 projects for cold storage, ice cream making or ice cream manufacturing industries, process plants, fish and meat freezing, as well as air conditioning such as international airports, office buildings, and shopping malls. Sri Pranjpai is based from in Pune, and this is his postal address, his contact number, then the email and the website. So I request all of you to visit the website where you can see lot of information available and very useful information. Now I request our speaker of the day, Sri Paranjpai, to take over. Ravi?
Okay, you
Yeah.
can see my screen now. Okay. Good evening
sir.
to
Yes,
all
sir.
of you.
Yeah, we can see it, sir.
Yeah, good evening to all of you, all the listeners. And this is last but one session, session 6. Today we are going to discuss very unusual applications, that is for use of ammonia for comfort air conditioning. If the time permits, I will also cover use of hydrocarbons in air conditioning for this session. Let us see how the time goes on. The major introduction which I want to do, last time we discussed cold storage applications. Cold storages and comfort air conditioning are the main applications of refrigeration and air conditioning. 90% people, more than 90% people know that ammonia is used for industrial refrigeration for any field, whichever we listed in our session 2 on ammonia properties. So I'm not repeating those applications, but it is used everywhere in cold storages, ice plants, everywhere. Very few, rarely, very few consultants, designers, or end users, they use ammonia for comfort air conditioning. Now I will give you a little bit of background why this is happening. See, we Indians, our culture, if you know, is 5,000 years old and is the oldest culture over the world. And we are very calm and quiet and docile people. Lot of people from abroad they came, dominated us, conquered us, and ruled us. Initially, the Mughals contacted us. Even the Alexander came to India to conquer India. Then this, after the Mughals, long stay of Mughals, then the Britishers entered and they took over. And it took a big struggle for us to overcome and get an independence in 1947. So we are, if you ask me, my personal opinion, we are the followers of the people. We are not the rulers. We have only 50, 70 years experience as a ruler, and you are seeing what kind of democracy and what kind of problems we are going through. So we have been following these all foreign countries, especially in even including in refrigeration air conditioning field. There are only 3-4 companies who are doing refrigeration, to be very frank with you, whereas there are more than 100 various consultants companies who are involved in air conditioning projects. So our today's subject, I am trying to convince people that what is happening world over. Normally what happens, people don't give the information from abroad and they try to sell which they want to discard, and that is how we are getting all these man-made refrigerants, and whatever they are investing, they are pushing it on us, and we readily accept it because, as I mentioned, we are followers. We have never taken our own lead, and our own engineers are so intelligent that they go abroad and they manage all the big companies, even in air conditioning, refrigeration. If you see, lot of top people are from India. So having covered this background, my effort today is to show you what is happening world over. And then we have to decide, our young engineers especially, have to decide that we have to take a lead and do something which is out of normal practices. Yes, there could be one or two failures, but failure don't get bothered down. Only failure is the only teacher in life. Success, repetition does not teach you anything. Even you know that development of electrical bulb, Thomas Alva Edison had so many, more than 100 failures before he succeeded. So failure, don't get bogged down by failure. Out of failure only we learn. Having covered this background, let's now go now to next slide. Few first slides. I'm just repeating what we have covered, so I'll go very fast. The natural refrigerants are ammonia, carbon dioxide, air, water, sulfur dioxide, and hydrocarbons. We covered this last time. And the hydrocarbons are methane, ethane, propane, ethylene, butane, isobutane, etc., etc. So these are the natural refrigerants. Now we have to think, what is the need of use of natural refrigerants in air conditioning? So we have gone through in our earlier sessions, the natural refrigerants do not have global warming. Selection of refrigerant is known to the mankind since the life came to Earth. So we know all the drawbacks and all the plus points of this refrigeration. Now we want to proceed ahead, and we want no regret solution, that later on which our next generation should not blame us that these refrigerants which were introduced had these many problems. So we want environmental safe solutions. The current situation of global warming we discussed, there are two issues. One, today we are facing the biggest issue is global warming, and 40% of the world's production is consumed by air conditioning refrigeration industry, and out of that total air conditioning refrigeration industry, 40% is consumed by comfort air conditioning. So this is ASHRAE journal printout seminar. Kindly, I have given the reference, so you can go through it if you want. And the next slide is also a repetition that direct global warming because of the leakage of refrigerant is only 10%. The indirect global warming because of the energy consumption is 90%. So we come to next conclusion that we must have a refrigerant which is energy efficient besides its global warming properties. Uh, we saw that global warming leads to increase in carbon dioxide percentage in the air, and that is causing problems. So these are the tolerable limits. We had gone through these limits earlier, and uh, now we go to next slide. The various conferences leading to acceptance of use of natural refrigerants which took place. The first was Montreal Protocol, which phased out CFC refrigerants in 87, but it didn't talk about global warming. The Kyoto Protocol in 1997 decided to reduce the emission of global warming refrigerants. The next agreement was Kigali Agreement in October 16 to phase out global warming refrigerants, and then the EPA SNAP rule made it more specific that we need to phase out 134A, 404A, and 410A refrigerants, which have high global warming potential. Next came to Paris Agreement, November 16, that they decided that in 30 years' time we must phase it out. So there was a time limit. And the last agreement was Katowice Poland Agreement, COP24, on December 18, which limits the temperature rise to 2 degrees centigrade. The next slide is okay. These are the global warming. 404A, 410A, 407C, as you see, have high global warming potentials. So ammonia position we need to discuss. Ammonia has been continuously used as a refrigerant. Initial practice use vapor compression refrigeration was developed. This is an ASHRAE position paper, which is an important document which I wanted to show you. Approved by ASHRAE board in 2014. Ammonia has been continuously used as a refrigerant, and initial practice in vapor compression system was developed. It has remained the main refrigerant used in industrial systems because of its superior thermodynamic property and cost. This is an ASHRAE document approved by ASHRAE Board of Directors on 14. Restrictions of CFC, HCFC, and many HFC refrigerants focus the attention on ammonia to emerge as one of the major refrigerant that when released to atmosphere does not deplete the ozone layer and has no global warming. ASHRAE considers, this is important, that continued use of ammonia for food preservation and air conditioning is important. ASHRAE promotes a variety of programs such as sorry, next slide. Okay, so then next is ASHRAE Journal 2017. This slide I think we had seen earlier. Changing rules along the use of high global warming refrigerants has been one of the hottest topics. Following the phase out of ozone depleting refrigerants, under significance new policy SNAP, they have decided to ban these refrigerants. Okay, let's go ahead. We had seen these slides. These are the refrigerants which are getting banned, and what are the left ones are these refrigerants, which is R290, R600, that is hydrocarbon, and natural refrigerant, that is ammonia. Now this cycle repeats. We are coming back again to use of natural refrigerants from where we started in 1834. And this slide you will find, I am repeating this, that ammonia has the highest energy efficiency or coefficient of performance. So it is the least global warming refrigerant, and it is also least TEVI effect, total equivalent warming impact for the compared to any other refrigerant. And this is a general summation side which shows uh, ammonia efficiencies for both cold room, for secondary fluids, that is for cold storages, for low temperature applications, and for freezing applications. The first one is for chilled water, that is air conditioning. So now the next slide, I will start with applications of ammonia with some properties of hydrocarbons mixtures. The advantage is these blends sometimes give better refrigeration capacity, better oil solubility, and of course, the main advantage is reduced toxicity. This is the statement made by Mrs. Monica Witt from Germany in Condenser magazine, November 2008. So next we go to, we have seen all the compressor developments or condenser and evaporator developments in our session 4, but we'll quickly go through ammonia compressors. Now people, when they want to use for air conditioning, they want to use for smaller capacity also. And for smaller capacity today, if you see, people don't use ammonia because compressor is not available. Compressor is so big that minimum tonnage is required 20 ton capacity, 15 ton capacity, below which we have got to, whether we like it or not, we have to use uh, man-made refrigerants. So this is the effort done globally to develop the smaller compressor. This is only 7 kilowatt, which is a 2-ton compressor. So for a 2-ton cold rooms or for 2-ton process halls or anywhere, we can use this compressor. This compressor is still not available in India. I don't know if anybody has purchased, but this is a package which was exhibited in a Chillventa exhibition in Germany, showing these compressors and the ready-made package. And this slide also I showed you last time. This is a hermetic ammonia scroll compressor, very, very important scroll compressor. I didn't discuss in great details last time, but I will tell you this compressor, as I have mentioned, that copper is not compatible with ammonia. So what these Japanese people have done, they have encapsulated the entire electric motor so that we don't lose the efficiency of copper and still it can be used in a hermetic compressor. So this is a compressor which is using copper winding motor, but it is totally encapsulated, so it does not come in contact with ammonia refrigerant. And this is its cut view. If you see, this winding is totally enclosed in a casing. From here to here there is a casing, so it is not coming in contact with ammonia. And a new electromotor technology, this is what has been specified. New electromotor technology has been developed now using encapsulated copper winding and aluminum windings for semi-hermetic ammonia compressors, a hermetic scroll compressor for small capacity. This can be 1 ton, 1.5 ton, etc. can be used. And the next most important thing is direct expansion evaporators with miscible oils are also developed and can be used for ammonia system. This is a semi-hermetic ammonia compressor with copper winding and encapsulated copper motor. So efficiency is not lost, motor efficiency is not lost. And on the right hand side, you will see the picture of a total package, a semi-hermetic compressor, condenser, evaporator, and control panel packaged into a plant. Why not? My challenge is to new companies who are startup companies, why not build similar package in India? We have the compressors now, may not be semi-hermetic, but we have open compressors of 10-ton capacity available. Let us start with it, and then gradually, as we develop confidence, switch over to this type of thing. I'm sure they will be available in Indian market in another couple of years. This is also a screw compressor with aluminum winding motor developed by Cobelco Mycom. This is a CO2 compressor. As I mentioned, it is a very small 1/7 size of the normal compressor and can be used for car air conditioning, bus air conditioning very easily. These are the sizes of condensers, heat exchangers, etc. And important component I want to show you is shell and plate heat exchangers. These are becoming very popular now in ammonia application. The water is on the shell side, and these plates, if you see, these are the welded plates through which the ammonia flows. So the heat transfer coefficient is very, very high, and it offsets the disadvantages of water quality, which are not very good, because PHE plate heat exchangers require a good quality of water. This shell and plate does not require as high a quality as PHE, because you can see the shell is bolted. You can remove that, remove the plate, and you can clean the water side easily. So this is becoming very popular. Our main objective in use of ammonia air conditioning is to reduce the toxicity effect of ammonia. As I have told you, flammability is never an issue. Ammonia does not get flammable. Its flammability temperature is 650 degrees centigrade, which we never reach in our any of the plants. So toxicity is an only issue, and the effort is to use low charge ammonia systems as much as possible if you want to use of ammonia into air conditioning plants. And therefore, these shell and plate heat exchangers help a lot in reducing the quantity of ammonia, and as well as when quantity is reduced, toxicity is reduced. The next is aluminum coolers, very, very important, very compact compared to your steel coolers, and requires very less quantity of ammonia, because heat transfer coefficients we saw are much better compared to stainless steel or any other refrigerants, any other materials. So these become compact, again the ammonia charge is reduced. These are the plate type heat exchangers, all of us know, and alternate plate is water, alternate plate is ammonia. These are very popular. Now the main slide which I want to show you, which I have not shown so far, is these new types of heat exchangers, which are having, if you see, very small diameter holes. The intention is to reduce the quantity of ammonia without reducing the efficiency. So these are also becoming very popular for heat exchangers like condensers and chillers for ammonia plants. And the latest development which I wanted to show you for ammonia is this enhanced tubing for spray chillers. Spray chiller we did not discuss up till now. I will show you now advantages of a spray chiller for ammonia. So these tubes, the top tube you will see it is both internally and externally heat transfer area is increased. Internal heat transfer area helps in retaining the liquid film along the wall and thereby increases the heat transfer area. And the bottom tube is stainless steel tube. The next slide is this ammonia spray chiller. I did not show it last time. In order to, normally in ammonia we use flooded chiller. Now, flooded chiller, if you use, the water is in the tube and ammonia is on the shell side. So there is a lot of ammonia quantity is on the shell side. And one of the reasons why ammonia flooded chillers are not being used for air conditioning because of the large quantity of ammonia. As I mentioned, our entire intention is to reduce the quantity of air. And the spray chiller, if you see the advantage of spray chiller, the diameter of the shell, the same installation has been replaced. The flooded chiller installation has been replaced with the help of spray chiller. The shell diameter has been reduced from 60 inch to 48 inch. Tube length has been reduced to 17 feet. Tube OD has been reduced from 1.25 to 0.75 millimeter. Number of passes have been reduced from 6, 7 to number of only 2, and the pressure drop is reduced. And most important is, look here, the ammonia charge. Ammonia charge is reduced from 10 pounds to 0.5 pounds per ton. So 9.5 pounds per ton are saved if you use spray chillers. I'm glad to inform you that in Pune, one or two consultants, they are using spray chillers in their ammonia plants. The next slide is, now, as we discussed, we are now aiming at low charge refrigeration systems if we want to use it for air conditioning. Now, this slide we had seen that what is low charge system is the charge should be less than 1.3 kg per kilowatt. And as we discussed, many packages have been now developed which has charges lower than 0.3 kg per ton or 0.06 kg per kilowatt. This is the systems which are available. This is not my statement. This is ISRE Journal, January, March 2017. If you see the article by Star Refrigeration UK, Mr. R. Lamb has written this article. The next slide, low charge ammonia systems. This is Andy Pearson from UK, IIAR presentation. Optimum charge systems have become very common. Generally accepted benchmark is 1.3 kg per kilowatt or 0.8 pound per ton. And as an example of a project, at Valvin Garden City in France involved such a standard. The system was designed with cooling capacity of 7,500 kilowatt, that is 2,160 ton, and with PHE condenser chillers. The job specification stipulated the charge should be less than 250 kg per chiller, and eventual solution was developed with 3 water chillers, each of 2,500 kilowatt and requiring only 238 kg ammonia instead of 250 kg per chiller, which is less than 0.0952 kg per kilowatt. Now, DX low charge ammonia systems. We are going to discuss DX. If you use direct expansion, then the refrigerant charge is substantially reduced. Why do we prefer DX, although it is not as efficient as a flooded system? But for small capacity plants, DX ammonia systems are becoming also popular because it reduces the risk for workers and production people associated with ammonia leaks, because there is a very less leakage, which is less than 16 to 25%, which is allowable limit. Reducing regulatory obligations. In many countries, there are regulatory obligations. What should be the quantity of ammonia into a system? If it exceeds that quantity, there are very strict energy audits and regulations. So people want to avoid it. So reducing regulatory obligations is one of the requirements. The DX systems can be used up to say -7 degrees centigrade, but normally 90% cases they are used for positive temperature, which is an air conditioning temperature. For freezer application, they are not suitable because the evaporator performance drops very drastically. We have seen last time the advantages of flooded systems over ammonia system, the DX systems. In a DX system, if you refer the pH diagram, the percentage of gas going into the evaporator is very high and the efficiency of the evaporator drops drastically. The company known as Colmac USA has patented this system design for direct expansion. You see, this is their system, direct expansion system, evaporative condensers, and then compressor, and then there is a suction trap to ensure that the liquid does not enter into a compressor. These are direct expansion evaporators. Thermostatic expansion valves are available on direct expansion ammonia systems with Danfoss and other manufacturers from USA. So this is a system which uses very low charge refrigeration systems. The next slide I will show you. This is a direct expansion and the recent trends. Now we will let us see how the low charge packages ready to use for air conditioning, similar to your Freon packages, have been developed for ammonia systems. So this is a package we developed in India. This is developed in one of the companies in India. This is used with PHE chiller, and you will find PHE condenser both. The PHE chiller is alpha level U2 chiller and has been used for low temperature. The compressor is reciprocating compressor and is a factory made package, and more than 5-6 such packages have been. This is designed by Pentair Norway, and with their help we made these packages in India. This is a chiller package, ammonia chiller package. In this package you can see a flooded chiller which is insulated, and condenser is also there at the bottom, and this is a compressor motor set on top of it. This is a package chiller. Now when you are using both condenser and chiller in a PHE design, your refrigerant charge comes down drastically. But still you require an accumulator on top of it. But you can see we can use now Newton accumulator, so which will reduce the charge of refrigerant into an accumulator. The ammonia receiver is there. Ammonia receiver has a lot of charge. We discussed last time that you can use high side float and reduce the and delete the receiver entirely. So where the ammonia charge is maximum is ammonia receiver, ammonia chillers, ammonia condensers. So when these all three attempts, you use latest technologies, your refrigerant charge, you can come within the limit of 1.3 kg per kilowatt, which is an international limit. The next slide shows Sabro, Denmark, a package chiller using reciprocating compressors and condenser chillers. The next package I want to show you, which is a shell and plate. You will see both the condensers and chillers. The condensers and chillers are shell and plate. The advantage, I have already one advantage I told you, that on water side you can clean it, but the second greatest advantage is charge of ammonia is reduced substantially. And the third The most important advantage is even if your ammonia leaks in the condenser and chiller, it will not come out of the system. It will remain in the shell and no harm, no damage or no trouble takes place for the operators anywhere. So I'm just telling you these new technologies. This is a shell and plate chillers. We have not started, to the best of my knowledge, in India so far, but we can start, we can import these and we can start using it, or the new startup companies can develop these locally and it will have a great potential, good market in India, those who are manufacturers. This is a very important slide I wanted to show you. This is, look here, this is an ammonia chiller package with hermetic scroll compressor using copper winding motor, the scroll compressor which we saw earlier, and this is a package which is ready, factory made package developed by Mycom Japan, and now these packages are available. I don't know whether they will be able to, they are permitted yet to export it, but someone can import it and try it out also in their plants. This is an UK, UK chiller, air cooled application. So your condenser is air cooled. You delete the cooling tower, pumps, etc. The advantage is it can be totally factory assembled and you can use it, just lift it by crane and install it on the roof. So this is a UK based company and they are making these packages. Now this is water cooled chiller package. This is 0.1 kg charge, less than 0.353 kg per TR. Both PHE condensers chillers developed again by this company and it has won very prestigious awards at international exhibitions. This is a slide which I showed you, that with plate type heat exchangers and reciprocating compressor, open type in between. So long as we are not getting hermetic compressors or semi-hermetic compressors, we can certainly use these our open type reciprocating compressors. The next slide shows a totally factory assembled package with PHE condenser and PHE chiller. Both are PHE is factory made and factory produced, factory piped, factory tested. So chances of ammonia leakage are totally eliminated. Our current systems, we do 90% work at site and during doing that work, we create problems and we have leakages. So this is very important that if a factory made ammonia package, which a manufacturer guarantees that there will be no leak of ammonia, lot of people will be bold enough to accept such packages. See this is a Italian package, Zodec, a big package. A man is standing and you can see compared to man's size, it's a very big package. More than 2000 kilowatt, 700 ton, 800 ton package, all factory assembled. Everything on the left hand side, you can see this chiller, package, piping, everything. So I'm just showing various packages. This is a very important package and becoming very popular because this is kept on the rooftop. You can just lift the whole package. It is with air-cooled condenser, not as efficient as water-cooled, but is much better than your 404A or 410A air-cooled packages. The performance and the efficiency is much better. So these packages can be put on the roof. The advantage of putting it on the roof is, as you know, in case with water precautions we take if ammonia leaks. That ammonia leakage, ammonia we have discussed in our second seminar, that ammonia is the only refrigerant which is lighter than air. And from the terrace, if it leaks, it will go into the atmosphere without harming any of the occupants of the building. A chilled water is circulated in the building, not ammonia. It's a chilled water package and getting very popular abroad. Look here, this is a package ammonia chiller, a big one installed on a rooftop with the vibration mounts. You can see these vibration mounts to isolate the vibrations coming to the roof. Here I would like to give you one very interesting my experience why these vibration isolators are required. I did one project, not air conditioning project, air conditioning project using reciprocating compressors, but not with ammonia, with R22. And that was at Mahalakshmi Tasicon House, you must be knowing, near the bridge, where there is an offices, and we installed the package on the rooftop because there was no machine room space. And the rooftop package was installed in an office. The office belonged to one Parsi gentleman, Mr. Topiwala. And you know, these people are very decent people. And he called us, he called me, and he said, look here, Paranspe, your air conditioning system is working very fine, but I have a problem. I said, what is the problem? He says, banks are not accepting my checks. I said, I was wondering what it has to do with this. He says, when your air conditioning plant works, the vibration gets transmitted to my office, and when I sign the check, the signature gets totally distorted. So this is how he told me. So he says every time I have to stop the air conditioning plant if I have to sign the checks. So I'm just giving you a story just to tell you the importance of vibration isolators in a system. These are the ready-made packages, rooftop packages installed on a rooftop with covers and everything. Well-made packages. Are we making such packages in India? No, we are still promoting use of 404A, 410A, 134A because as I mentioned in the beginning, we are followers. We are not the leaders. We don't want to take any lead. If foreigners come with these packages, once they develop and once they discharge their other refrigerants because of the Kotowise protocol, then they will say, oh, you have a ready-made ammonia package, why don't you use it? And then we will start using it. Why lag behind? As our Prime Minister has said, let us take a lead. Let us be the leaders and let us teach the world that we are no lesser competent than other people. Anyway, this is a message to young engineers, new engineers who want to enter this field. This package, the earlier slide has been reopened to show you the internals of the system. The three compressors are there. The uh, LP vessel is there, low pressure vessel, and the ammonia pump circulation system has been used, and the chilled water is produced. You can see the chilled water pipes which are going inside the building. These are the insulated pipes, chilled water pipes going inside the building. So this is a package on the rooftop again. These are the few people who are making ammonia ready-made package chillers available with air-cooled packages. These are the companies mentioned: Refcom, York, Mycom, Evapco, etc. up to 200 kilowatt and charge less than 400 grams per kilowatt. So it is very low charge systems, and water cooled systems are still further lower charger, and these are the companies ABB, Gram from Denmark, Sabro, Mycom, Evapco, all of them are developed these. People will not develop a package if there is a requirement of one or two packages. These are being sold in number of systems in comfort air conditioning plants abroad, and we are still keeping our eyes closed. So ammonia air conditioning applications, this is what I am going to today's topic. Mainly I have covered all the background, low charge systems, new components, new shell and plate heat exchangers, direct expansion systems, etc. etc. So ASHRAE journal, uh, so this is William McCloskey, Executive Vice President of Baltimore, said IAIR, that is International Institute of Ammonia Refrigeration, and its members must dedicate themselves to negative perception about ammonia, not with this, but general public. This includes the faulty perception code practice prohibits use of ammonia in installation in metros. He cited an example that several cities, just see this very important, Chicago, which is the most populated city in USA, has restrictive code practices. Restrictive code practices means limit the charge of ammonia. They have more than 140 urban ammonia air conditioning installations in operation. The air conditioning systems in USA include Chicago W. Granger office building, 40-story Blue Cross Shield building, and also ammonia chillers for air conditioning. So these people tell us to use 404A, 410A because they have spent money and they have to recover the cost. And we are the fools. We are the third world country people and we readily buy them. We don't want to try anything on our own. Now I am going for a next very important slide. All the airports in the world. Do you know any airport in India using ammonia? No, not a single airport. But you see the world over, Oslo Airport, Norway, Heathrow Terminal 5, Singapore Changi Airport, Stuttgart Airport, Copenhagen Airport, Düsseldorf Airport, Zurich Airport, Christchurch Airport, New Zealand. And these are the office buildings. KWN Greenpeace headquarters in Vienna, Berlin train station, where the population, as you know, is very high on the train stations. They use air conditioning for building complexes. Use of ammonia again in comfort air conditioning. Telephone exchanges in Copenhagen use ammonia as a refrigerant. Roche headquarters office building in London uses 930 kW ammonia refrigeration system supplied by Star Refrigeration. SAB building Sweden uses 4 ammonia chillers. Mulligan later sorting center Switzerland. Johnson Controls, who have a presence in India also, and they have done one or two jobs with ammonia with air conditioning in India also. So they are trying this to sell to the people. Ozenium is in Strassland, Johnson Controls, again 500 kilowatt AC plant. Direct expansion with soluble oils in large processing halls in factories like fish freezing, ice cream, meat processing, etc. Thermal storage systems for malls, cinema halls, etc. use ammonia because the usage is only a few hours and remaining time you can produce thermal storage. Space shuttles Now, very critical application. People say don't use ammonia in a public place, but space shuttle, which is such an important application, uses ammonia. Why? Because the system is very compact. Hanover Trade Fair building, Homerton University hospital, there are all patients, all occupied areas. Here, as you see in India, our people are telling just the opposite. No, don't use ammonia, don't use ammonia. People are so ignorant that West Bengal government, headed by Mamata Banerjee, since there were one or two accidents in potato cold storages, they banned use of ammonia in a occupied, publicly occupied areas. So, which is a nonsense because they are not aware about such ammonia systems. So, it is our duty to educate people and tell them that ammonia system can be as safe as any other refrigerant system. Oslo Airport, I will just read, an air conditioning installation with Oslo, Norway was commissioned in 1998. So it is nearly now more than 22 years. Total refrigeration capacity 6,300 kilowatt, that is more than 2,000 tons, and they use 5 because at that time screw compressors in 1998 were not very popular, so they are using 5 280-ton reciprocating compressors and 2 of 160-ton Sabro compressors reciprocating. Uh, this is one of the largest and most advanced airports, handling 16 to 18 million passengers per year and 80 aircrafts per hour take. Oh, this is old news. And building area 18,000 square meter, commercial area 2.7 square kilometer, and total area 13. So it is using ammonia as a refrigerant. This is the plant room at Oslo Airport using Fabro reciprocating compressors. The Heathrow, this is the latest airport, Terminal 5. Heathrow Airport is not new one, but the Terminal 5 is the latest terminal. And they decided their earlier terminals are using man-made refrigerants. But to make just read this slide, to make the vast Terminal 5 virtually independent from ozone depleting and high global warming HFC, heating and cooling is done by dedicated energy continuous supply of hot air, both for hot heat pump as well as for air conditioning. All chillers operate with zero ozone depleting and non-global warming refrigerant ammonia. It is a natural substance was selected by the airport authority because they recognized that as a future-proof solution offering excellent properties, no risk analysis, safety review removed last problems regarding the system design and installation, and the ammonia would not pose any greater risk to public. The airport staff, other than conventional large chiller solution, in fact, large ammonia chillers have already been used in more densely populated areas without any safety compromise. You can see one of the four chillers. This is at the Heathrow Airport Terminal 5. It is done with total ammonia refrigerant. And we are not doing it in India still. Our consultants still specify 404A, 410A, 134A chiller packages. This is the Stuttgart Airport, Netherlands. Grasso Netherlands have done the job. This is using again ammonia refrigerant. Grasso installed ammonia system and Terminal 5 at Stuttgart using two chiller packages. The ice band system is designed to work along with already installed refrigeration circuits with man-made refrigerants to get maximum efficiency in low load conditions. Ammonia gives very high efficiencies even when the load is low. A public building in Hanover, it has been air conditioned using 3 air-cooled 700 kilowatt, only 150 kg of ammonia, new design PHE, and very important, I wanted to show you spray type shell and tube evaporator, which I showed you just now earlier, has been used. It has a better efficiency, 30% better than 134A, low charge 0.02 to 0.5 kg per kilowatt for dry and flooded evaporators, high discharge pressure. It can be used very advantageously for heat pump, whereas we saw other refrigerants, man-made refrigerants, have very low critical point, so they cannot be used for heat pump application. Whereas ammonia can be very successfully used for both heat pump as well as for comfort air conditioning or for low temperature. So it is a very versatile refrigerant. I saw in Switzerland, I might have told you, a plant where the atmospheric temperature was less than 20 degrees centigrade. It was 10, 12 degrees centigrade. But discharge pressure was ammonia discharge pressure. Air cooled packages installed on the rooftop were having very high pressure, 28, 30 bar. So I was wondering, we normally in India, if the discharge pressure exceeds 18 kg or 18 bar, we tell customer that something is wrong with your system. Please check your condensers, water flow, etc. Here I asked the operators, I said, look here, when the ambient temperature is low, so low, are you not consuming a lot of energy by keeping such a high discharge pressure? He said, look here, Paranspe, I agree with you. You are from a country where you don't have much of heat pump applications, but here we see overall efficiency as a heat pump plus air conditioning. And at these conditions, we are getting optimum efficiency because we are a major use of ammonia is for heat pump application. So then I understood why they are running it at such a high pressure. These are the modern ammonia packages, 700 kilowatt package using PHE. And this is again a full high occupied area, Migros supermarket in Zurich, using ammonia system for air conditioning, not only for air conditioning by circulating secondary refrigerant, but even the display cases, refrigerated display cases are using ammonia as a refrigerant in a fully occupied space. So remember, very important thing, in a fully occupied space, to use ammonia refrigerant requires lot of confidence that my ammonia system will never leak. I guarantee it, it will be as safe as any other freon systems or man-made refrigerant systems. I have used one ammonia plant with the help of for one consultant, ITC and Srini Mega Food Park in Coimbatore with secondary glycol refrigerant in the IQFs, in quick freezers, but the main plant is ammonia. The ammonia, so this is an ammonia glycol system. The glycol is stored in a tank and it's circulated through your system. A very important slide which I want to show you. The latest slide. This is ASHRAE HVAC news, industry news. If you are a member of ASHRAE and if you then you must be getting industry news. If you go through that, I read it very recently in about 2 years back, An ammonia heat pump has been installed to heat and cool 40,000 square meter apartments. Just look at it. Apartments where is fully occupied by people and business premises in Netherlands. The office complex earlier was Philips and will use 800 kilowatt of ammonia heat pump system fitted with two screw compressors for space heating as well as winter and comfort air conditioning during summer. One of the compressors is working and one is standby. The heat pump was selected to heat and cool the building complex due to very high efficiency of ammonia, zero global warming potential, and nearly zero ozone depleting potential, said the developer. Why we are not thinking in this manner, I do not know. This is the complete package including electrical starter panel wiring for post and telegraph building in Copenhagen. This is an office, fully air-conditioned office complex. Johnson Controls using ammonia for air conditioning office premises using water 4 ammonia chillers, each of 2 megawatt capacity. And this is the last slide which I want to show you on ammonia package chillers. This is a Logan City Council in Australia, South Brisbane. This is, you see, very important. Again, it is using shell and plate heat exchangers, both condensers and chillers, water cooled with cooling tower and reciprocating compressor. Uh, so you will see uh, the building has been now converted. Earlier it is using man-made systems, man-made refrigerants, but converted old-fashioned existing R22 chillers based on air to new water-cooled ammonia system. Not only did this new system reduce Logan City's council's consumption by around 50%. Can you imagine? But it also eliminated all environmental risks associated with future releases of chemical refrigerants. We don't know these man-made chemical refrigerants, what risks they pose for the future generation. So these Australian people did not want to take that risk. They say ammonia is known to us for ages. We know its properties and we will use it. The new water chillers has a combined capacity of 1200 kilowatt, nearly 350-400 ton, and the state of the art with built-in speed control, de-superheaters recovery, less than 25 kg charge of ammonia per unit, with computerized monitoring system. The new ammonia system is replacing two existing R22 plants. The performance of the new system has exceeded our expectations to such an extent that the chilled water supply temperature set point to various air handling units had to be increased. That gives a lot of energy saving. This, of course, improves the energy efficiency further. The new water chillers feature an IPLV value. You know IPLV value, that is integrated part load power consumption values, is close to 10. A vast improvement over R22 system with a COP of only 2.8. So can you imagine, it is not only in Europe, globally, in Japan. In Japan was totally against ammonia, but now they have realized. I showed you MyCom compressors, MyCom packages using ammonia and promoting it. So this is a latest system. This is a star refrigeration office building with rooftop units, and this is an entire complex, that is a what we call city. A total city has been air conditioned with ammonia. and this is San Diego, California project using ammonia for residential district cooling, what we call district cooling, replacing traditional HFC refrigerants. The COP 3.7, which is improved, and 156% more efficiency. You know how our electricity is important. We want to save energy. So start using ammonia and you will never regret it. Similarly, low charge packages have been manufactured. We saw that has been provided for department for air conditioning with ammonia charge of only 213 pounds with chilled water at 45-degree Fahrenheit supply and air-cooled condenser at a bakery in Portland, that is USA, with 440 pounds of ammonia. So I think I have covered. This is again one of the aquariums, underwater aquarium, and it is an oceanium, which is totally submerged underwater, is using 400 kilowatt ammonia systems. Chilled water is supplied at 6 degrees and 2 Sabro reciprocating compressors have been used. This is the seafood industry, very important. US Seafood Seattle will install ammonia freezer equipment after being found. Now look here, this is just a seesaw, just opposite of our Indian government. They found that using R22 is violation of Clean Air Act because it leads to global warming. So their acts are very, very different by releasing ozone depleting R22, and therefore for the vessels, processing vessels, they changed over to ammonia. This is an ASHRAE news, not my news. ASHRAE November 2017 ASHRAE journal. And this is the winter sports, totally indoor snow park, fully air conditioned. So I have covered, I'm sure I have given you a lot of information and food for thought for you to think about ammonia, why we should change over to ammonia, why we should develop systems which are absolutely foolproof, and why we should go ahead with less ozone depletion, less global, no global warming, and besides that, be very highly efficient systems so that our energy, the country's energy, is saved by nearly 30 to 40%, and we can use this energy for more useful purposes like agriculture and for other production purposes rather than wasting it for comfort air conditioning. Now we go to our second refrigerant, which is carbon dioxide. We discussed the properties very briefly in our earlier seminar, but why carbon dioxide is not very, very popular in India because it has a very high discharge pressures. You see, at 40 degrees centigrade, which is very common in India, the discharge pressure is 91 kg as against our ammonia pressures of 18 kg. And also you can't condense carbon dioxide because its critical point is 30.98. So beyond this point, it is always in the gas form. So there is no condenser in ammonia supercritical systems. It is a gas cooler and not condenser. So carbon dioxide in India is not very, very popular, but globally people are using it. It can be used right up to minus 70 degrees, 60 degrees temperature, because at minus 78 degrees, it is atmospheric pressure. Whereas ammonia boiling point, that is the atmospheric pressure, is minus 33. So below minus 33, ammonia works under vacuum, whereas carbon dioxide will not work under vacuum. It will continue to work as a positive pressure. So where do we take advantage of carbon dioxide? We know its advantages, drawbacks. It has zero ODP, zero global warming potential, but these are the advantages. High density, so very smaller system. I told you nearly 6 to 8 times smaller compared to your standard system. In a car air conditioner, it can be kept into your glove compartment. The entire air conditioning unit can be kept in a glove compartment instead of under the bonnet. So very small piping, so you save huge insulation cost, very high heat transfer coefficients, low pressure losses, etc., etc. But it has very great disadvantages also. Very high discharge pressures, very low critical temperatures. So flexibility of operation is limited, and therefore we use it in cascade system, which is an expensive system. It is heavier than air, so not like ammonia, it goes into the air, so it can concentrate, can go up carbon dioxide, and can create a problem for occupied people if it leaks. 400 ppm is allowable, so this is again an issue. Odorless, it is odorless, so it requires detectors for detecting it, not like ammonia. Ammonia can be smelled even there is a leakage of 25 ppm. Solid phase above atmospheric pressure, so opening safety valves is very dangerous to atmosphere. It immediately freezes up. Liquid to gas expansion ratio is very high. Liquid traps and gas traps must be avoided, etc., etc. Moisture is not tolerable in carbon dioxide less than 5 ppm, whereas ammonia, you know, is very generous. Lots, buckets and buckets of ammonia water has been removed without even customer noticing it that the system is having so much water content. So only gas charging is possible, no liquid charging, etc., etc. So carbon dioxide in India, what we can use: high stage 134A or 404A, low stage carbon dioxide, or high stage ammonia, low stage carbon dioxide. This is man-made refrigerants. This is what I will recommend. I'm designing one plant and I'm using this in one of the Ratnagiri plants for Gadre Marine for fish freezing, high stage ammonia and low stage plate freezers with carbon dioxide. With carbon dioxide plate freezer, our freezing time has come down from 1.5 hours to 1 hour. So earlier we were taking 11 cycles per day. Now with carbon dioxide we can go as high as 20 cycles per day. So your production nearly doubles up when you use carbon dioxide for low stage. Secondary coolant as a brine in supermarkets can be used as a carbon dioxide as a secondary coolant. CO2 in domestic applications. You know, Olympics took place and they were banned from using ammonia or other refrigerants. So at that time, Coca-Cola company used, instead of 134A, which is a high global warming potential, carbon dioxide for their 550-liter refrigerators. And this gave the system operating with 20 to 30% less energy, even in supercritical range, that is condensing temperature above 31 degrees centigrade. So it was a gas cooler because Australia, the temperatures can go up. So supercritical region, but still it gave 20 to 30% less energy compared to 134A. This is a cascade ammonia CO2 system for supermarket. High stage is ammonia, cooling tower, carbon dioxide, high stage cascade, compressor, thermostatic expansion valve. As I mentioned, is direct expansion system. and here both PHE condensers, PHE chillers, and this is a low stage CO2 carbon dioxide system. The next slide, this is a package I had shown you earlier. This is CO2 ammonia cascade package. Reciprocating compressors on top, Sapro compressors, and condenser chillers at the bottom. This is ammonia CO2 brine system used in Holland. The CO2 is used as a secondary refrigerant for circulation into occupied area. Ammonia is in the machine room. So instead of chilled water or any man-made refrigerant or glycol, if you use CO2 as a secondary refrigerant, your efficiency improves by 30 to 40%. This is a CO2 bus air conditioning installation, and it's operating in Scandinavian countries where the temperatures are not beyond 31.6 degrees centigrade, but total CO2 is used for bus air conditioning. So this is another use of carbon dioxide. And then we come to, we have still about 10 minutes. So we go to hydrocarbons as refrigerants, which is again a man-made refrigerant, where you can use hydrocarbons. Hydrocarbons can be used in domestic refrigerators and freezers. It can be used in bottle coolers, ice cream freezers, commercial freezers, beer coolers, beverage coolers, dehumidifiers, heat pumps, supermarkets as a secondary refrigerant, as we saw just now, and small air conditioning plants. These are the most popular hydrocarbon refrigerants: butane, isobutane, propane, propylene, ethane, and ethylene. Their properties have been given. Again, as I mentioned, all these my slides will be available for you to see on internet, and ISRE will circulate this. Which are the substitutes now? 134A currently we are using for household refrigerators. It can be substituted with R600A. R134A for commercial applications, we can substitute it with a mixture of 290 propane isobutane. 404A and 57A can be totally replaced with R290 and R1270 and their mixtures. 417C can be replaced with 290 R1270 for air conditioning and heat pump applications. For industrial process plants, already people are using in India propane as a refrigerant, because industrial plants has lot of other hazardous chemicals compared to ammonia and propane. So the operators are very well conversant with risk management. Next, our last session, we are going to cover all safety measures to be taken, how to cover the risk for both for equipment as well as for human beings in case of accidents. Accidents don't happen by planning. Accidents happen by default. So we must be prepared. What is known as hazard analysis. We must be able to do hazard analysis of every plant, and 407C can be replaced, 410A can be replaced, R23, R14 can be replaced with these refrigerants, high temperature applications, low temperature cascade applications, deviations due to capacity, air conditioning plants, etc. Our next slide, hydrocarbon as a risk pool. Now, as I mentioned, butane has been used in more than 300 liter 300 domestic refrigerators, and now finding use in smaller commercial systems. Propane is used in central air conditioning systems. Reports, very, very important, 10 to 30% energy savings with minimum charges can be used in current installation using, it can is a direct replacement for R22 in an existing system. You don't have to replace any other thing. Just replace the refrigerant with propane and you will be able to save lot of energy. Unilever uses propane in 360 liters, their ice cream freezers, and they have said that compared to 404A, an average 9% power saving has been reported in all their ice cream freezers. Hydrocarbon butane is very successful in more than 3 million domestic refrigerators currently being used. Pepsi, as already I have told you, 150 grams refrigerant consumes 27% less energy than 134A. With the support, very important slide, with the support of from international organizations, we can also get a support from international organizations. China has converted so many air conditioners plants, 18 their 18 production units making air conditioners. They have converted it to 290 refrigerant with a capacity to produce 450,000 units per year. Can you imagine? They are using it all this in their country, and they have supplied 3 other compressor manufacturing plants to produce 54 lakhs compressors per year. And up to August 19, 1,60,000 units have been installed as room air conditioner. In India, Godrej has introduced isobutane for domestic refrigeration. I am using it in my household Godrej refrigerator with isobutane, and it is quite efficient as compared to our normal air conditioners. This is a propane air conditioner, as I told you, room air conditioner, and has been produced by a company known as GREE, and it's sold more than 3 million refrigerators. This is a propane room air conditioner developed by Godrej and Boyce in India. In India also some companies are taking a lead in use of hydrocarbon refrigerants. Propane for air conditioning, Germany, the municipal corporation has installed propane in cooling servers, computer servers, and the system is 20 kilowatt using capacity. This is used by Euromon, Germany. Propane for heating and air conditioning, 2 into 250 kilowatt shopping centers. A shopping center in Switzerland has used propane for comfort air conditioning, and the units are designed to work around the clock, having high COP and energy efficiency. The system per unit uses only 15 kg of gas. This is a propane CO2 cascade. This is a propane central refrigeration plant in KPC, in Kirloskar Pneumatic, or Johnson Controls, and so many companies are also manufacturing in India propane for industrial chilling plants and are supplying to various industrial refrigeration plants. So this is a propane plant, propane package for petrochemical duties. And this is my, I think, last slide. It is just 8:30. I'm on the dot, on time. I wanted to change the perspective of the people and the general perception of the public that ammonia is harmful and don't use ammonia for air conditioning. I think I've shown you enough number of slides, enough number of countries who are changing very rapidly to natural refrigerants, ammonia, carbon dioxide, and hydrocarbons, and getting rid of these man-made refrigerants, especially Europe, China, and other countries except USA, because USA has developed this man-made refrigerant and they must promote it because they have to recover their cost of development. So they will go on promoting their 410A, 404A, and other systems. My only request, this is my personal opinion, it is not to offend anyone, but I request that give a sincere thought to use of these refrigerants, and maybe in few cases you may have problems, but out of problems only a solution will come and you will learn better and better. With this, I think I will take your leave, and our next seminar we will take all safety precautions in case the ammonia leaks, what needs to be done. Thank you very much. Thank you for patiently hearing, and I thank Ishray once again for giving me this opportunity to express my views and to make public aware about the ammonia system. Thank you, and I hand over back to the organizers. Okay, take it back.
Okay. Thank you, sir, for this exhaustive and excellent presentation where we have given all the experience you have gained in your service and you have, with passion, you have shared it with the entire audience here. Uh, we have learned a lot. There is naturally air conditioning can be done using ammonia as the refrigerant, and we hope that in India we start implementing more and more ammonia-based plants for air conditioning as well. We also discussed about other natural refrigerants, and let's all work towards using these natural refrigerants for air conditioning, which, as you had also mentioned, consumes more power, and we can where there's a scope for saving energy. So once again, on behalf of Ishre, we'd like to thank you for this wonderful presentation. And for the attendees here, your questions, whatever has been posted, are being answered by the speaker, Shri Paranjpeji, and the answers are being mailed back to you. So we look for more questions, and then you'll get the feed, and also we'll be giving you back the response from the speaker. We have also been providing the response sheets, so we request all of you to fill in the duly filled in response sheets for the webinar series, and uh, provide us your valuable feedback. Okay, thank you, and we'll again meet on coming Friday for the last seminar workshop on this series 7 series webinar. Okay, thank you. Ravi, if you have anything, please tell us.
No, sir. Hello.
Okay, yeah,
Okay.
thanks a lot.
Thank you.
Thank